Have you ever wondered why we live not on another planet, but exactly here on Earth? With 8 planets in the Sun system, why is only one truly suitable for life? And how is it that a gigantic nuclear reactor like the Sun has maintained its distance from Earth with nearly perfect stability for billions of years? Don't worry, this is exactly what we're talking about. The most critical astrobiological factor that allows Earth to host life is its distance from the Sun. This distance is approximately 1 astronomical unit, which mathematically corresponds to 149,597,870 kilometers. This distance provides the precise energy balance required for water to remain liquid on the planet's surface. If we were slightly closer, the oceans would evaporate. If we were slightly farther, a global freeze would occur. But the issue is not only distance. Earth's finely tuned nitrogen-oxygen atmosphere retains heat in a balanced way, creating a stable surface temperature. More importantly, its strong dipole magnetic field deflects solar winds and cosmic particles, preventing the atmosphere and water from escaping into space. Without this protective shield, Earth would most likely resemble Mars, a dry planet with a thin atmosphere. The fact that 2/3 of Earth's surface is covered with water is not enough on its own. What truly matters is the presence of land areas capable of sustaining vital functions. The carbon cycle, food chains, biochemical diversity, all of these depend on the interaction between continents and oceans. Now let's go a little deeper. Earth's internal structure and plate tectonics create a feedback mechanism that has preserved water and the atmosphere for billions of years. This mechanism produces a long-term stability that smaller celestial bodies do not possess. That is precisely why the Moon and Mars were unable to retain water for long periods. This idea is known as the rare Earth approach. In 2009, Loper emphasized a habitable loop in which water, atmospheric structure, the geomagnetic field, and plate tectonics operate together as a closed system. This system makes Earth not only habitable, but habitable for a very long time. So why hasn't this order been disrupted for billions of years? Because at the foundation of this system lies a balance that is difficult to perceive on a human scale, but works flawlessly on a cosmic scale. The balance between gravity and motion. At the center lies the Sun, containing almost all of the system's mass. This enormous mass effectively bends the space around it. As planets move forward through this curved space, they are also pulled by the Sun's gravity. The perfect balance of these two effects creates and preserves orbits. For example, Earth travels at about 108,000 kilometers per hour. If this speed were slightly lower, it would drift closer to the Sun. If slightly higher, it would be flung outward. Yet this delicate match between speed and distance has been preserved for billions of years. So why doesn't this balance break on its own? Because the solar system formed from a rotating disk of gas and dust. The angular momentum from that initial rotation is still conserved today. In physics, angular momentum does not change easily. Unless a massive external force interferes, this cosmic order continues. But can't the planets disturb each other, you might ask? This is where Jupiter becomes important. Jupiter's enormous mass captures or ejects wandering asteroids and comets. It effectively cleans the region where the inner planets reside. As a result, orbital chaos is greatly reduced. The solar system is not completely unchanging. On the contrary, orbits shift millimeter by millimeter, planetary axes slowly wobble, and the Sun gradually increases in brightness. However, these changes occur on the scale of millions and billions of years, making them negligible compared to human history. In conclusion, the order we observe today is not a coincidence. After the early chaotic periods, only the orbits that could remain stable in the long term survive, whether you call it long-term dynamical stability or a deeper mystery. So the reason the solar system appears unchanged is not a miracle, but the natural consequence of the fundamental laws of physics operating flawlessly over immense timescales. And that is why we live not on another planet, but exactly here on Earth.